And that's also true. Okay, chemistry time. We're talking today about chemical. This is the heart of chemistry. It's about chemical reactions.
That's what chemistry.
That's what chemistry. You can abbreviate the word reactions. It'll come up in this chapter quite a lot. You can abbreviate the word reactions. R, X, N, Z. Like the capital R, capital X, capital N is an abbreviation, an agreed upon abbreviation for reaction. Because we talk about reactions so often that it's nice to have an abbreviation. Okay, so the first thing we're going to talk about, not all, but the first 2/3 of what we talk about today should be reviewed from physical science if you had the privilege of having physical science. Some of you were pandemicked, and some of you had a class that made it very difficult for you to understand anything, and some of you went to moral. So everyone has a little bit of a handicap here, but the chemical reactions, the first thing we need to talk about is that this form, A plus B yields AB. What do we call these two things, and what do we call this thing, and how do we pronounce the other stuff? What are these? These are vocab words.
Reactants.
We're just all trying to be on the same page here. Reactants. What's this guy?
Products.
This is a product, singular, because there's only one. What's this?
Reaction.
That we say this yields. And this?
No, I can't see this. Reaction? A plus sign.
Plus. Yeah, very good. So A plus B, we pronounce this A plus B yields AB.
Synthesis.
Na plus Cl, sodium plus chlorine yields sodium chloride. Oh, check it out. Naming becomes extremely important because a lot of times, maybe you will be given this equation. Calcium plus oxygen gas yields calcium oxide. Well, what do I have to do? This might be the thing you're given on the test. What do I need to do first in order to balance it? It might say balance this. Calcium plus oxygen gas yields calcium. Well, what do I need to do first though to start?
Put them into the form.
Yeah, this is called the word form. I need to first get into a skeleton equation, which is just using the formula. I don't mean formula, I mean symbols. So calcium is Ca plus oxygen gas. Well, here's where the trick is for some of us who don't have a full understanding. What do I put for oxygen gas? O2. Why O2, Lily? You just made that up and you happen to be right?
Because it's one of those. I don't remember what
Yeah, you do. Someone remember, please.
I was thinking of it last
There are 7 of them. What are they? Diatomic molecules. So oxygen is one of the diatomic molecules. Anytime you see oxygen, especially if you see the word oxygen gas, but anytime you see oxygen or hydrogen or nitrogen or fluorine, chlorine, bromine, or iodine in an equation as a word, it means that thing too. So calcium plus O2 yields calcium oxide. Well, what's the formula for calcium oxide?
CaO.
CaO. But see, if you didn't know how to name and write formulas, you'd have a hard time with this. You might be like, is it CaO2? Is it Ca2O? IDK? Because I never learned how to name and write formulas. But you do know how to name and write formulas because you learned it. Is this balanced?
Nope.
Let's balance it. This is balancing practice.
2 in front of the Ca.
He says 2 in front of the Ca. Sure. I mean, we don't need it right
2 in
now.
front of the CaO.
Yeah, this balances it. What can we do to balance these things? Can I change the subscripts? No. So when balancing, only change coefficients. If you need a review on this, this is real, assuming that you already know mostly how to do this. If you need a review, you can watch the physical science videos about how to balance chemical equations because those are much, or you could watch a good YouTube video about how to balance chemical equations, probably.
Yours
But anyway,
is good, Mr.
thank you, Peyton. That is so nice of you. You can only change the coefficients. You can't change the subscripts in this. When do you change the subscripts? Well, when you're naming and writing formulas, you have to change the subscripts then. But when you're balancing, you can only change the coefficients, and you do so because the coefficients multiply each element in that compound. So if I have the 2 here, the coefficient 2, means I have 2 calciums and 2 oxygens. Do you see how that balances the 2 oxygens here, even though this one's a subscript? What is the goal of all this? What am I trying to do? due to the
Law of conservation.
law of conservation of mass. Thank you, Mitch. Conservation of mass by whom? He didn't call it this. Well, first of all, he was French.
Sir, Isaac Newton?
No.
Antoine Lavoisier.
Antoine Lavoisier with his 14-year-old wife. She's dead now. She's no longer 14. Antoine Lavoisier.
Do we need to know that?
He got the idea of the law of conservation of mass. I don't know, Peyton. Yeah, kind of. I think so. I can't remember if it's on the test or not. You probably should. I mean, he's a very important human being. As far as science history is concerned, he is
He's not
Third.
Sir
one
Isaac
of.
Newton.
He's not Sir. He's no Sir Isaac Newton. I know.
He's third.
For one thing, he's French, and a tax collector, and part of the bourgeoisie. So we can't have that. He got beheaded actually for being part of the bourgeoisie.
And how do you spell his last name?
And
Yeah, dating before dating.
Lavoisier. But that was fine back then. That was fine for a long time after that and a long time before it, so you can't judge him on that. Anyway, but due to Antoine Lavoisier's law of conservation of mass, what? What is the point of all this?
there has to be the same amount of stuff
Yeah.
on one side as there is on
Same amount
stuff.
of each element on each side of the, if I put side of the equation, you'll know what I mean. What is the dividing line? What forms the sides of the
The
equation?
arrow.
Yeah, this arrow, this yield sign is the dividing line. Reactants and products. I have to have the same number of reactants as products. Is that a funny drawing to you, Mitch? It seems like it is because you laughed. This is just the way it is. This is like a Venn diagram.
Or a butt.
Mitch, you have ISS. Okay. Let's talk about now. Do you have questions about this first of all before we go on? You will understand this as you get more practice. I would say at least 3/5 of you already understand how to do this. But do you have questions as we see
I
it?
understand it now even more just talking about it.
Yeah. And you just need more practice. As many things in chemistry. This is, for the sake of the video, we'll leave it at that. You will do more practice so that you can get good at it. But this is the basics of it. These are the theories behind it.
I already know it.
Oh my gosh, he's bad. I'm not supposed to.
Okay. Next thing we're talking about is the types of chemical reactions. We're gonna go over our bell work at this point. The types of chemical reactions. So write this down, please, because I want to get to the thing that will actually be new to everyone before this video is over, and I only have 16 minutes. So please write down types of chemical reactions. This should be a review from physical science. Types of chemical reactions. I'm just going to keep saying it until the board is fully erased. Types of chemical reactions. You can even start writing your heading. Types of chemical reactions. I'm going to start writing my heading now. Types of chemical reactions. How many are there?
You're lucky we're
5?
recording.
Wait, 5. Yeah, I think we are recording.
No, I know. I told Mitch he's lucky.
Because he's not taking a one single
No,
note.
because he is making
There's
me out, so I have to
nothing to
behave myself because I'm being.
Okay,
idiot.
the first type is synthesis. The second type is decomposition. Leave some room because we're going to do a little bit of describing of these, but I'm just going to write them up here to begin with. The third type is single replacement. I can never remember. I'm pretty sure the physical science book and the chemistry book use different words for this. Does your current book say single displacement or single replacement? It makes no difference. They're the same.
It's single displacement.
Single displacement in the chemistry book. Okay. Single displacement.
Oh, it's single replacement.
Okay, single replacement. Doesn't matter. They're interchangeable. The fourth type is double displacement. And the fifth type is combustion. There are more. And there is some overlap between these. For instance, and there's also things like oxidation reduction reactions, which kind of fall into these categories too. There are more, but these are the 5 that we talk about for inorganic chemistry especially. What's the general form? These are their names. What's the general form for a synthesis reaction?
A plus B yields AB.
A plus B yields AB. An example? Did anyone have one of these as an example that they did for their bell work?
Yeah, I did.
The one that we had up here a second ago, sodium plus chlorine yields sodium chloride. Now that I think about it, chlorine's diatomic, so that should have been, please don't put comments on this video. Comments are disabled for this video. That should have been Na plus Cl2. It should have been 2Na plus Cl2 yields 2NaCl. Write me an email. Okay.
Right. That
It's on the channel. You can see it. Okay, give me an example. This, so the record shows, the kicking motion I was doing was not at Mitch. I was trying to kick a cap away from his reach. No part of my body contacted Mitch's body. I did not kick him. This is getting more suspicious the more I talk about it. Someone please give me an example of a synthesis reaction.
What was that? What we did for the lab?
Mg plus O2 yields MgO.
Balanced?
No.
Let's balance it real quick for practice. I'm glad you chose this one because my lowercase g looks exactly like my 2, so that'll make it extra confusing.
Oh.
2 in front of the Mg, 2 in front of the MgO.
Okay.
Balanced.
Is this a synthesis reaction?
Oops, my hand is
I think so.
Yeah, it is. Is it a combustion reaction?
Yeah.
Yeah, it's both a synthesis and a combustion reaction, so there's already some overlap. Give me an example of a decomposition reaction. Did anyone choose decomposition as one of their reactions for the bell word?
HgO yields Hg plus O2.
Interesting you should bring that one up. Oops, sorry, I forgot to do the general form. I should have asked that first. A decomposition reaction is in the general form AB yields A plus B. We can kind of think of it as the opposite of the synthesis reaction. HgO, mercury 2 oxide, yields Hg plus O2. So once again, 2HgO, 2Hg. It's interesting you chose this one because this is the Joseph Priestley's experiment where he took what was called the red calcium mercury, mercury 2 hydroxide, mercury 2 oxide, and roasted it in sunlight to drive off the oxygen. It resulted in pure mercury, which you can, even at the time in the 18th century, they could tell when pure mercury was there as opposed to the calcium mercury, which was a red powder. So we started with this red powder used to treat venereal disease. You guys know about venereal disease? That'll be a different video. And then the result was pure mercury, which is a liquid, obviously, metal, and then this gas that was produced, which he called, eventually Lavoisier termed it oxygen, but Priestley in some of his drawings called it better air or good air, because remember it was the one where he trapped the mouse inside of it and it lived for like several hours instead of 15 minutes. You remember that? And he started breathing it, and he said, "I feel great." And then now we all breathe it all the time. No, I'm just kidding. People breathed it back then too, but he basically isolated the part of air that's actually useful. Decomposition reaction.
I feel fine.
Single displacement. Who has an example of a single? Well, I'm sorry. What's the general form of a single displacement?
AB plus C yields CB plus A? Or AC plus
Let's do it
B?
this way, Mitch, instead of the terrible way you're trying to do it. Let's do AX plus B yields BX plus A.
But mine was still right.
I mean, that's fine, but I use the different ends of the alphabet to show that we have different kinds of elements here.
AX plus B.
In this case, what are A and B both, probably? Well, what must they be, actually, for this to work?
Metals.
Metals. A and B are metals, and X here is some kind of anion. An example?
Aluminum plus hydrochloric acid.
Oops. Well, let me spell hydrochloric acid, right? I really did not leave myself on. This is taking up half the board, and this is where I'm actually writing all this stuff. Whatever, don't at me. What?
Yields aluminum chloride plus hydrogen.
Is that balanced?
Is it balanced? Good question, Pam.
Well, I'm just thinking, like,
Let's balance it.
do we have to squish more in there?
We're gonna have to
Let's
squish
say
more in.
H2, A.
H. Wait,
Oh, that bothers me.
you'll be alright.
I'm still gonna write it.
They use a giant one.
Oh.
Yes, Mr. Kind.
Uh-oh.
H by O
Did you almost just
C
gag?
D.
You don't have OCD,
plus H C O
please.
A L C O.
Ouch.
Balance, please.
C O.
Something, something, John Hancock. Now even King George can read it. You know my
Okay,
reference.
now we need
No.
3.
I'm prepared. I have the 3 writer. I just don't know where to put it. Please tell me.
3.
3 on the AL on both sides, yes.
Okay.
Oh, is that correct?
Well, let's
No,
see what happens.
actually,
No, let's leave it.
no,
and see
you
what we can do.
don't leave the 3 on the side, on the one side. On the right side.
Kyla's not the only person in this class. Someone please help her.
And
Stop,
then a
stop
2
touching each other and help.
in front of HCl, right?
No one helped me the last two.
Because Mitch, you're smart enough to get it all.
Let me give you a little assistance, Kyla. Here's a good way to start these. We need the practice. So here's a good way to start these. I would like you to start with things that aren't hydrogen or oxygen. That's usually a good way, especially oxygen. Leave till the end because on combustion reactions you can get kind of carried away with dealing with the oxygen first. So let's just start with the chlorine. We know we have 3 chlorine on this side and we need 3 over here, so we'll do that. 3 chlorine. It is still going to be a problem because what can I multiply hydrogen by to make it 3?
Nothing.
Well, no, not nothing. What is it? Tell me.
1.5.
1.5. Is that going to work? We can't put in non-whole numbers. So instead of multiplying that by 3, let's do 6 and 2, and we'll put a 3 here. And then we'll need a 2 in front of this. So we just kind of, Camden, to answer your what? We just kind of go back and forth. We start with one that we know is wrong, and then that changes something else. So then we change something else. So then we change the last thing, and eventually we get it right. What happens if you get it right? Wait, what's the matter with this? Isn't this still technically correct?
No.
Well, it is technically correct.
Divide by.
Yeah, if all of them can be divided by the same number, every single one, you can't, don't forget that you can't, like, if one of them is empty, like this O2 here, you can't divide all these by 2, because what is here, even though it doesn't show up? 1. So if you can divide every single coefficient by any one number, you have to do that. You have to basically, like in math, what do we call that? What verb in math?
Simplify.
Yeah, we have to simplify. We have to simplify. Okay, double displacement, general form.
AX plus BX yields BX plus, or AY plus BX. Alright, Lily. See that? Now it's a
I don't know.
contest. That's right.
AX plus BY yields BX plus AY. What do they do?
Switched.
Double switch.
Just like in Twilight, I bet this happened in Twilight. Someone was dating someone else was dating someone, and then they switched. Did that happen? Give me a better
That
example.
had to have happened.
Bridgerton? Come on, Kyla. You. This is the exact kind of television you watch.
No.
In fact-
I've never watched the Twilight movies.
It is the kind of reality television that my wife watches. She watches a show called, sometimes she watches a show called Love is Blind, and they're like trapped in these rooms. And this happens all the time.
Loves that.
They're all like, oh, I'm gonna date Jeffrey, and then Jeffrey's like, I'm gonna date Cassandra, and then Cassandra's like, I'm gonna date Paul, and Paul's like, I'm gonna date Jeffrey. It's all messed up. But no, they do switch each other around. Anyway, well, give me an example of this.
Dumb.
This one's interesting
I
because.
got one.
Okay.
Just give me a second. I'll find it. Where's my bell work? Okay. 2 PBO
PBO
plus C
plus C.
arrow.
But now, hey, this one isn't gonna work unless there's actually single replacement.
Yo.
And does it really just say plus C?
Yeah.
That's
Yo.
interesting. I didn't know this reaction occurred. That's not gonna work because that's not double displacement.
This is not double displacement.
Did I get
Let's use the one from our lab. We had sodium carbonate.
Sad.
We had sodium carbonate and copper 2 chloride, and it yielded copper 2 carbonate, and sodium chloride. Okay, now listen, for double displacement, it's extremely important that you write in these things. Sodium carbonate was in aqueous solution. This is the first time we've seen these. These tell us what is this little subscript? This should be like here, but I ran out of room.
Water.
It tells us the state. Aqueous means that this is dissolved in water.
This double,
was,
correct?
yes, this was dissolved in water. But copper carbonate came out as a solid. What do we call a solid that comes out of solution? Precipitate. And this was dissolved in water. How do you know when a double displacement reaction has occurred? Well, here's the answer. If one of the products, these only occur if one or more of the products is a liquid, a solid, or a gas. If everything's an aqueous solution, if all of this says aqueous, you write this. If it is all aqueous, no reaction, no RXN. Why? Well, imagine this hadn't happened. What if instead we had,
Don't erase.
okay, imagine if instead, I'm trying to think of something that would be soluble here. What if we had sodium fluoride plus lithium chloride yields, well, it'd be sodium chloride plus lithium fluoride. Well, all of that is dissolved in water, so we wouldn't see anything. It'd just be mixing two things together. It'd be like blue Kool-Aid and red Kool-Aid. They just mix. No reaction happens. In order for the reaction to happen, something has to, this guy is what tells us the reaction. What did this look like in the lab? Just a plain old blue Kool-Aid? No, when you made this in the lab, what did it look like?
Was this the green one?
Yeah, it was what? That wasn't the screen.
It was opaque.
It was opaque, yeah, because it was a solid, and that tells us that a chemical reaction has occurred. Or if bubbles, like if it forms a gas. Bubbles. Oh, that's a gas. Or if bubbles. Or if bubbles. Quote, Mr. Kime, March 17th, St. Patrick's Day. I'm opposed to the Irish. What?
You said or if bubbles?
Or if bubbles.
Or...
Okay, and the last one is combustion.
Wait, what does that says if it is not what?
If it is not, if it is all in aqueous solution. If all of the products are in aqueous solution.
If it is all aqueous.
Yeah, if it is all, that's absolutely no better than what it was before. If it is all in aqueous solution, no reaction has occurred. Okay, and then the combustion reaction is the last one. In a combustion reaction, something has to combine. X plus O2 yields XO2. Or there can be other combinations, but this, like if X is a metal, it would form a metal oxide. If X is a metal. If X is a hydrocarbon, it would be X plus O2. Oh, sorry. Let's put some other thing.
It does.
I'm just going to write the word hydrocarbon. If it's some hydrocarbon, what might a hydrocarbon be?
See that word right there?
Methane is a hydrocarbon.
RXN?
No, the P word.
Carbon.
Yeah, it has hydrogen and carbon.
Yeah.
If it's a substance that has both hydrogen and carbon, and only hydrogen or carbon, then it's hydrocarbon plus O2 yields CO2 plus H2O. This would have to be a metal. The X has to be a metal. So metal plus oxygen yields the metal oxide. Hydrocarbon plus oxygen yields carbon dioxide and water. There are others, but that's the combustion reaction has to combine with oxygen, and heat and light have to be produced. That's part of the definition of a combustion reaction.
So what are those shapes?
These are supposed to be letters. This is the letter L. This is the letter S, and this is the letter
Bubbles.
G.
So liquid,
Solid and
gas.
gas. Yep.
Oh, okay. Mr. Chemical.
Okay, we did run out of time. We straight up ran out of time. You must review the thing where it talks about the reaction series on page 293. You have to. This is actually the two actual things I want to talk about.
Wait,
all of this was review from physical science. Yeah, 293. Review the reaction series, and then, well, I guess just do all of lesson 3 on your own, because that was the main thing we're going to talk about today. No, we'll probably talk about this a little bit on Monday when we go over the chapter review. Also, I think I did get to it in last year's video, so if you're terrified of it, you can go back and watch that segment of last year's video. Do you have questions before we end, because it's time to go?
No.
I just